So, I'm Tushar, and here I'm presenting my work of CML Assignment 1 Part A. So, before we begin, let me just show what sir have asked us to do. So, just going over through it, like if we open the task that has provided to us, we have to make a video explanation to duration of 5 to 8 minutes, in which we have to do the following tasks. We have to identify the point group of the crystals that suggestor have given us in the class. So after when we have identified the point group, like we have to make 2-3 PPT slides and to explain the morphology of the crystals that we have given, and we have to explain that the point group of the crystal and why we think that it is a suitable point group. So I have prepared the presentation for the same. Let me just start presenting it. So if we go to slideshow, if I start the presentation, so here's the front page, here's written CML-102 Assignment 1 Part A, presented by Tushar. So let's begin. So basically we have provided with the sample of rock sugar. And how do we know it? Like when sir provided the sample to us, they said it's basically a unknown compound, and they didn't tell us what is exactly it is. But after when we test it, like we shouldn't taste it actually, but yeah, we tasted it and we came to know that it's a rock sugar. So basically rock sugar is a sucrose, which is 99% sucrose, and 1% is of the content of the water is there. Sucrose is a compound with the formula of C12H22O11. Basically sucrose contains one molecule of glucose and one molecule of fructose. The rock sugars are essentially in yellow and the white colors, so that can be obtained naturally in the yellowish form or the white color. Here, yellow rock sugar is obtained directly from the sugar cane, preserving nutrients. Like we just take directly from the sugar cane, and we didn't do much purification, so the yellow rock sugar contains the natural minerals and taste and everything, so it preserves the nutrients. On the other hand, why we have white rock sugar? It is obtained by the further purification and the color removal. So it is basically the purest form of the sugar. It has been like many filtration process has been done over the yellow rock sugar. Then we obtain the white rock sugar, and thus white rock sugar is the purest form of the sugar available. So here we are provided with the single crystalline white sugar. So we are provided with the crystals of the white sugar. You can see in the images here. Let me zoom this out. If you see here, we have the crystals of the white sugar. You can see like these are the crystals here. These are basically white rock sugar. So let's move ahead. So let's come to the main part of the video. Here just we have to talk about the morphology. Like what we the compound that we have provided is a white rock sugar, and the morphology of the white rock sugar, which is basically a sucrose. So it's been identified that sucrose crystals tend to form the monoclinic prisms. Like many of my friends also saw that thing, that it was looking like a hexagonal shape. So many of us thought that there should be some six-fold symmetry, but when we look closer towards it, like joining the two hexagonal forms, it will just form the monoclinic system. So and actually the sucrose crystal tend to form the monoclinic prisms. So sucrose crystallizes in the monoclinic system. So and the basic characteristics of the monoclinic system is as follows: is the unit cell length of the monoclinic system is given as A not equal to B not equal to C. That the that the cell parameters are all different, and the angle between the axes, the two of the axes are mutually perpendicular to each other, and one of the axes is not perpendicular to each other to the other two. So it is a basically monoclinic system. So when we analyze it, we come to find that the sucrose crystallizes in the monoclinic system, and it has one peculiar characteristics. It is like it has two full rotation axis and one mirror plane. How we got that? I will explain the next PPT. So the point group of the monoclinic system is typically given by 2 by m. It implies that it has two full rotational axes and one mirror plane perpendicular to the axis. Let's see how we got this. So here is the explanation of 2 over m point group. So basically the first image here, if you able to see my mouse cursor here, it basically show the top view of the crystal here. So here, as you can see, there is one mirror plane given here. You can see this is the mirror plane. Oh, let me just click back to it. Okay, so if you look towards it, there is a two-fold rotation axis along this plane. You can see it here, and then perpendicular mirror to it. So basically it's like 180-degree rotation around one axis, and then we have a mirror which is perpendicular to that axis. For further clarification, we can see here. So basically this point here, which has been shown here, it shows the axis of two-fold rotation. So if we just rotate 180-degree from here, it will still look the same, and perpendicular to it we have a one mirror plane. So it's basically two-fold rotation along with a perpendicular mirror. So we, from this we can conclude that it's a 2 by m point group. So the two-fold rotation axis is been shown here, and you can also see the mirror plane here. So basically we have concluded that the white rock sugar that we have given is like follows the monoclinic system, and it has a point group of 2 by m. So thank you for listening to me. Here it is the part A of the assignment. Thank you. Have a good day. Let me close the video. Sorry. I don't